first section is on functions and graphs. We do a little bit on the calculator, not much, but we'll get to that. But first thing they talk about in this section is this diagram, which explains the different kinds of numbers and the terms that we'll use to describe them. So simplest kind of numbers, we start with our counting numbers. And what do you think is the first number in the counting number set? Have a guess? Yeah, 1. Yep. And they don't include negatives, they don't include 0, they don't include fractions or decimals. They include numbers from 1 and up. And the reason we don't just stick with counting numbers is because when we start to do arithmetic, sometimes we get answers that are not counting numbers. Sometimes we do. Okay, depends on the calculation. So Josh, could you give me a counting number?
5.
5. All right. So we got 5. And Natalie, can you give me another counting number? 3. Now, if I take 5 plus 3 and add them together, I get 8. Is 8 a counting number? What do you think? Yeah, that's fine. So adding those together, no problem. Subtracting them, also not a problem. 5 minus 3 is 2, and 2 is a counting number. But let's try something like this. 3 minus 3. If counting numbers are the only kind of numbers that you're familiar with, then there is no answer in the counting number box that you could put right there. Okay. The answer that goes there goes outside of counting numbers. So this is the first time we have to kind of expand beyond counting numbers because we need a way to represent nothing. When you're counting, you don't really have to worry about the idea of nothing because if you had nothing in front of you, you wouldn't be counting things anyway. You would only count things if you had one or more of them to count. Right? So the next numbers we look at are whole numbers. The only difference is whole numbers now have the concept of nothing, which is a 0. But even with whole numbers, we can still run into some calculations that would be a problem if we don't understand more than whole numbers. Right. Let's say we did something like this. 4 minus 6. Okay, if I showed that to somebody, in like first grade, I said, 4 minus 6, they say, you can't do that. You can't take away more than you have. And practically, you can't do that. Like if I'm holding 4 things in my hand, you can't take 6 from me. It's not possible. Well, that's where it gets a little bit more theoretical. It is possible to take away more than you have. And if you do that, what kind of numbers are you working with? You're working with negatives. Okay, so again, practically, you can't take away more than I'm holding, but you can take away more than you have if you want to deal with the concept of a negative number. Okay, and that's what integers are. So now integers have numbers like -3, -2, -1, 0, 1, 2, 3. But there's still even just basic arithmetic that you can't get an answer if all you use is integers. So if you had something like, let's say, 3 divided by 2. I want to take these 3 objects that I'm holding. I want to divide them equally between 2 people. Well, I could give one to one person. I could give one to the other person. But now what do I do with this last one? There's no way I can give this equally to 2 people. The only way I can do that is if I break it in half, right? And start giving out pieces of things, parts of things, fractions. So that's where rational numbers come in. So rational numbers extend the kind of numbers that we use to include fractions and decimals. Okay, so I'll write that down. So rational numbers include fractions and decimals. And for most everyday purposes, I would say those are probably as complicated of numbers as the average person would use. Like if you were cutting a piece of wood, and maybe it doesn't have to be 10 inches, it doesn't have to be 11 inches, it has to be 10 5/16, right? So it's 10 plus 5/16 of a fraction of the next inch. It's a part of an inch, not an entire inch. If you were cooking, maybe a recipe calls for 2 1/3 cups of an ingredient. Okay? Not 2 cups of the ingredient, not 3 cups, 2 cups, and then a fractional part of the next cup. So fractions and decimals, very, very common. So if rational numbers are all the numbers that include fractions and decimals, irrational numbers are the numbers that cannot be written as fractions and decimals. Does anybody know a number that you cannot write as a fraction? Yeah. Yeah, pi. So that's a number that we can't write as a fraction. Other things are like square roots. Now, if you take the square root of a perfect square, that you can write as a nice number. Like the square root of 4 is 2. But if you do something like square root of 2, you type that in on the calculator, you get a decimal, and it never repeats. There's no pattern to the numbers. Okay, we could, if we had a different calculator, we could list even more decimals, and you'd never see a pattern in the numbers that's consistent. If you don't have a pattern here, you're not going to be able to write a fraction. If you did something like this, you might look at it quickly and say, it just looks like a bunch of numbers, but there is a pattern. It's 285714, 285714, 285714. And I could show you more decimals if the calculator could do it. But it has a pattern that repeats. So that's a fraction. Here's another one, a little easier to see that the pattern repeats. It's just 0.6 repeating. That's rounded up because the next digit is a 0.6 and it rounded. Okay, but it's just 0.6 forever. Okay, so that is a fraction. Now, somebody had asked in another class about, well, are there any other numbers besides rationals and irrationals that we talk about? Not in Algebra 1. Okay, in Algebra 1, that's all you talk about. Those are called the real numbers. Beyond that, there's something called like imaginary numbers. We're not going to get into that today. Okay, but those are the kind of terms you'll need to know. And I want you to, for a minute, just think of these words as like different places. Okay, starting out with like a smaller place and then getting bigger, bigger, and bigger. So like counting numbers, think of as like Boston. Whole numbers, Massachusetts. Integers, even bigger. We're thinking of that as like New England, the United States, and Earth. Okay, so it's getting bigger. If you are in Massachusetts, are you automatically in New England? Yes. If you're in New England, are you automatically in Massachusetts? No, it doesn't work that way. So a whole number is automatically an integer because it's inside the integer box. But an integer is not automatically a whole number. And I think if you think of it as places, that kind of helps it to make sense. Okay, same thing here. A counting number is automatically a real number because Boston is on Earth. Okay, things like that. Some of these number sets have symbols. So with integers, a lot of times you'll see it written with a capital letter Z. And it's got that extra line in the middle. Rational numbers, a lot of times you'll see that with a Q. It could be like Q for quotient. You can remember it that way. And real numbers, the symbol you'll see for those is an R. So whenever you see those three symbols, they stand for those three words. Okay, you also might see something like this. You might see an R with like a plus next to it. Does anyone have an idea what that symbol might mean based on the one that I wrote down? Yeah?
A real number with a, I forgot what they're called.
Yeah?
A real number with a positive integer.
So just a positive real number. Yeah, it still could be a fraction or a decimal. So it doesn't have to be an integer, but it's just some kind of positive real number. You could also see like a minus there, which would mean a negative real number. And you can put the plus or minus on any of those symbols. Any questions on that? All right, so we're going to look at a few different properties with real numbers. To describe these properties, I'm going to have to use some letters. I'll use the letters A, B, and C, and those can be any real number. Okay, so that's the biggest category of numbers, basically anything that's not imaginary. Okay, so the first property we're going to look at is the one that says A plus B equals B plus A. So when you add two things, you can switch the order and you get the same answer. Does anybody remember what the name of that property is? Begins with a C. Yep.
Commutative.
Yep, that's the commutative property. And some of these properties also work for multiplication. The commutative property does work for multiplication. You can multiply two numbers together, and if you change the order, you still get the same answer. Now, how about subtraction? If you subtract two numbers, can you switch the order and get the same answer? No. So a commutative property doesn't work for subtraction. How about that second property? It's not commutative because the order did not change. ABC, ABC. What we did is we changed the grouping. We changed what's grouped in parentheses. Anyone remember what that one's called? This one begins with an A. Yeah?
The associative.
Yep, that's associative. And if you think of like the word associate, which kind of sounds like associative, associate means like, if I ask you who do you associate with, it's like who's the group of people that you talk to. So it has to do with groups. And in math, parentheses are how we group things together. Okay, let's do the other one this way. So the identity property. So for addition, the identity property is something you can do to a number that doesn't change it. So what can we do with addition that would give you back the same answer you started with? Yeah, Ariel?
You could just add 0 to it.
Right, we could add 0. Adding 0 is called the identity property for addition. Now, would times 0 be the identity property for multiplication? No, what would it be for multiplication? Timesing by 0 doesn't give you back what you started with, Josh.
1.
Yeah, so with multiplication, timesing by 1 gives you back the same thing you started with. Okay, so that's identity. And the last property is right there. We have an A and then in parentheses B plus C. And below it, I have AB plus AC. What property is that? Yep.
Distributive.
Yeah, that's distributive. So the distributive property can be used at any time you've got something on the outside of parentheses and then a plus or a minus inside parentheses. You would not do distributive if you have multiplication like this. You don't do 3 times 4 and 3 times 2. You just do 4 times 2 in parentheses is 8. 8 times 3 is 24. Okay, so distributive property doesn't apply with something like that. All right, so any questions on the names of those properties? Or what they mean? Okay, so as we went over them, I told you some of them apply to multiplication, like commutative does, associative does. The identity does, but it's a little different. It's times 1, not times 0. Distributive does not. Okay, but the first 3 all do. All right, so let's look at an example where I'm going to give you some steps. Oh, is that the next one? Oh, that's the next one. All right, so before we get to that one, if I write something like this, is that an equation? 3x plus 4. What do we think? Ben?
No.
No, that's not an equation. Okay, you can't solve, equations can be solved. There's no way you can solve that for x. What's it missing to make it have an equation? Maggie?
An equal sign?
Yeah, it needs an equal sign. So, if something has an equal sign in it, that makes it an equation. That by itself is an expression. That's not an equation. So here's 3 different kinds of equations. Some of them aren't true, but it's still an equation. So this first one, 5 equals 2, that is an equation, but it's a contradiction. Okay, it's an equation that is never true. And you might end up with something like 5 equals 2, like if you were to solve this in Algebra 1, like 2x plus 5 equals x plus 2 plus x. So if I gave that as a question and asked someone to solve it, you could start by combining like terms. And then if you subtract 2x from each side, it cancels out. And you're left with the statement 5 equals 2. Well, that's a contradiction, which means this equation can never be solved. Similar to that, but instead of ending up with a different number on each side when you're done, you end up with the same number on each side. That's called an identity. An identity is an equation that is always true. Okay? It's the opposite of a contradiction. And the top one is what we call a conditional equation. It's an equation that could be true if you pick the right value for x. So in this case, what would the value of x be that would make it true? Yep.
6.
6. Yep. It would be 6. Okay, so conditional equation, identity, contradiction, all just different types of equations. Questions on those? All right, and now I'm going to give you the example that I was mentioning earlier. And what I'm going to do is I'm going to write down a step, and I'm going to have you tell me the name of that step. Okay, so this is the first thing I'm going to do. 2 times x plus 2 times 3 equals 6 plus 2x. So I did something on the left side. Can anybody tell me what property I used on the left? Yeah.
Distributive.
Yeah, that's the distributive property. Yep. So the goal is to make the left side look like the right side in 3 steps. I just want you to tell me the name of the property in each step. So that's distributive. Now, there really isn't a formal name for what I'm doing here. But to get what I had up above and turn it into what I have down below there, what did I basically do to the left-hand side? I just took it and I did what? Yeah. Yeah, I would just simplify it. When you just do out arithmetic, I would just call that simplifying. Now, the left side almost looks like the right, but the left side is in the wrong order. Well, we can change the order, and you still get the same, it's the same thing, it's equivalent. So what property allows me to change the order of what's on the left side, and now it matches exactly what's on the right? Yep.
Commutative.
Yep, the commutative property. Okay, so this kind of problem could work 2 ways. I could give you the steps like I did. You tell me the name, or I give you all the names, and then you show me how to do the step. But that's it for properties. So any question on the first topic? Okay, this section has maybe like 4 topics, 5 topics like that, but they're all pretty short and kind of simple. Okay, next topic, coordinate system. Okay, not even a 2D coordinate system, just 1D. So in a one-dimensional coordinate system, we usually call that a number line. Positive numbers go right, negatives go left. And the 0 mark on your number line, that is the origin. Now, once you create a number line, bless you. The most basic thing a number line allows you to do is to compare something here to say something there. You can compare these 2 numbers to each other. When you are comparing numbers, there are 4 symbols we can use in math to describe how that number compares to that number. Anybody know one of the names of the 4 symbols that I'm thinking of? Yeah?
Greater than.
Yep, greater than. What's another one? Yep.
Equal to?
Yep.
Greater than or equal to?
Greater than or equal to. Yep. Another one. Yep.
Less than.
Less than. Yep. I think we got most of them. There's just one more. Less than or equal to. Okay, so those are our 4 inequality symbols. Greater than or equal to. Less than or equal to. And those are symbols that you use to compare one number to another number. So when I have something like this, that might be how an answer to an inequality would look. The value of my number is bigger than 3. We can write an answer like that, or we can also graph an inequality. Okay, to graph an inequality, we need a number line. On the test on Friday, if you have to do any graphing, there'll be a number line on the screen. And it's very easy to graph on the computer. If you ever get stuck on the test and you're not sure like what button to click, like how to do something that's related like technology-wise on the test, I would help you with that. But if you're not sure like what button to click because you don't know how to do the problem, it's not a technology issue, that I won't help you with. Okay. If anything, like you're not sure how to use the testing program, I don't want you to get a question wrong because you don't know like how to use the computer. Okay. All right. So when we're graphing on a number line, one way to do it is to put a circle, and there's 2 kinds of circles. Does anybody know the two kinds of circles that I'm thinking of. Yep, Ariel.
The one, so it's an open circle where there's no inside, and then a closed circle where there's an inside.
Yep, so you get the open and we get the closed circle. And you use each one in a different, depending on your symbol. If your symbol has the equal to, you fill the circle in. If your circle doesn't have the equal to, you don't fill it in. Okay, so that's the first thing we have to do. We have to put a circle, and then we have to shade. Now, with an inequality, especially if it's written like this, there's an easy way to tell which way you have to shade. If your inequality is set up with the letter on the left, then the inequality symbol, and then the number on the other side. Letter, symbol, number. The symbol will always point the way you need to shade, okay? As long as the letter is on the left. If the letter is on the right, then that doesn't work. Okay, so let's look at those two inequalities. Okay, so first question is, how does the one on the left compare to the one on the right?
How do they compare?
Yeah, how do those two inequalities compare to each other?
They're the same thing, basically.
Yeah, they're the same thing. Yeah, they're exactly the same thing. One of them has an x and a positive 2. The other one has an x and a positive 2. And the inequality sign is pointing at the 2. Same thing with that one. It's pointing towards the 2. Now, if you were going to write it as an answer, I'd accept either one of them. But which one is in the order that we want? The left one or the right one?
Left.
Yeah, we want to go with this one. Because then the inequality sign tells us to point, or points the way we need to shade. All right, let's make a number line. Again, on the test, number line will already be made for you. Braden, what kind of circle do I need here? Open or closed?
Close.
Yep, closed circle. And what number would you put it on?
Number 3.
Yep, put it on 2. Okay, so we got the circle. Now we need to shade. Sadie, which way am I going to shade?
Right?
Yeah, we're going to shade in the direction it's pointing. So shade to the right. So that's how you graph x is greater than or equal to 2. Any questions on that? Let's try another one. All right, so same question I had last time. How does the inequality on the left compare to the one on the right?
Same thing again.
Yeah, it's the same thing. I'm just showing you two different ways of writing it. This is the one that we would prefer, though. Variable on the left, number on the right. All right, let's make our number line. 0, 1, 2, 3. All right. How about Martine? What kind of circle do we need on this one? Open or closed? Yep, and shade which way?
To the left.
Perfect. Yep, that's it. Any questions on that? Okay, how many people have seen the open closed circle before? Yeah, pretty much. That's, if you've ever done graphing inequalities, that's usually the symbols they use. Now, in our book, you're going to see a different symbol in place of the closed circle. Okay, our book uses a bracket. It means exactly the same thing. So let me show you how it looks. but it's just a bracket instead of a circle. So if you had your number line, instead of putting a closed circle on the number 2, this symbol is a bracket. Okay, so we're going to put a bracket on the 2. One thing you got to think a little about with the bracket is which way you're going to shade, because the bracket needs to face the way that you're going to end up shading. Okay, so as far as what you're going to see on a test, I'm probably, if I have you graph something on a number line, I'm going to stick with the open and closed circle. But I could give you a multiple choice question and just give you this as a picture, right? And then say, what does that mean? You have to look at that and know, oh, bracket means it has the equal to, it's to the right, so it's greater than or equal to. Okay, so our book's going to use a bracket in place of a closed circle. What do you think it would use in place of an open circle? What other symbol might make sense? Anthony?
It was the parentheses kind of thing?
Yeah, it would use a parenthesis. So bracket means you can include the number greater than or equal to. Parenthesis means you have to be strictly greater or less than, not equal to. All right, so same idea. Use your parenthesis. Look at which way you're going to shade. Put your parenthesis on the number. And then shade, in this case, to the left. Okay, that might be new for some people. Never seen those symbols before. But it's the same thing. Right, any question on that? All right, so what if we want to graph something that doesn't go on forever with an arrow? Everything we've done has had an arrow. What if it's like between two numbers? Like I want to graph between 1 and 10. Well, for something like that, we can write a conjunction. So a conjunction can be written two ways. At the top here, that's the short way. At the bottom, that's the long way. They mean exactly the same thing. This part, x is less than or equal to 9. X is less than or equal to 9. That's where that part is. And this part, x is greater than or equal to 2. X is greater than or equal to 2. It does get switched around, but that's because the x is in the middle. It always has one number on the left and one number on the right. So this basically means every number between 2 and 9, and you can include the 2 and the 9. So if I was going to graph this one, how many circles am I going to need?
Two.
Yeah, I'm going to need 2 circles. The first one is going to go on what number?
Two.
First one's going to go on 2. And what kind of circle is it going to be?
It's going to be closed.
Yep, it's going to be closed. Filled in circle. Tom, how about my second circle?
Also closed.
Closed on what number?
9.
9. And now where do I shade?
In between.
Yeah, we're going to shade in between. That's generally what a conjunction looks like. So one thing you got to be pretty comfortable with is taking a conjunction that's combined together the short way and writing it out the long way, or taking something that's written the long way and turn it into the short way. Let's take something like x is greater than or equal to 1 and x is less than or equal to 4. Let's see if we can combine that to make it the short way. We'll put the answer in this box. What's going to go in the middle in that box? Yep. Yep, we're going to put the X in the middle. And look at the box up above. Where was the smaller number? On which side of the X? Yeah?
The left side.
Yeah, if you want to set it up so your inequalities point to the left, put your smaller number on the left. So 1 on the left, bigger number on the right, and you always have your inequalities point towards the smaller number. And if you want to check if you did it right, break it apart and look at it. There's the first one, x is less than or equal to 4. There's the second one, x, a 1, and it's pointing at the 1. It's exactly what we had up above. All right, so that's pretty much it for inequalities. Okay. Any question on inequalities? Okay. All right, so that's like the second and third thing. We talked about the number line, and then we talked about inequalities. All right, next topic, absolute value. So absolute value, some people think of it visually as how far away something is from the number 0. Since it's a distance, what kind of number would you never have when you're talking about distance? Maggie?
Negative.
Yeah, you never have a negative. Okay, so absolute value will never be negative. It can be 0, it can be positive. And those are different things. 0 is not positive. So it can be 0 or positive. Okay, so if you had the number 6, put a dot on a number line at 6, how far away would 6 be from the number 0?
6, right?
Yeah, it would be 6. How about if you put a dot on negative, I think the next one is negative 3. All right, how about negative 3? If you put a dot on negative 3, how far away would that be from 0? Yeah?
3.
3. Yeah, it's 3 units on the other side, but we don't care about what side it's on. Absolute value is just how far away is it. Okay, any question on that? So one thing we'll use absolute value for is to find like the change between two numbers. So like if you had a test grade of 81 and then you got a test grade of 94, and you wanted to know what's the change between those two grades. This would be the formula to figure it out. Okay, I called it change, distance, same thing. What's the distance between your two test grades? You normally wouldn't say it that way. But you could say what's the distance between 81 and 94 on a number line. You just subtract the two numbers that you want to find the change between, and then take the absolute value. Now, in this case, the order you subtract them in doesn't matter. Now, I said earlier that the commutative property doesn't work with subtraction. Why am I saying the order doesn't matter inside the absolute value bars? Yeah?
Because it'll always be positive when it comes out.
Right. The only difference between subtracting things in different order isn't the number that you get, it's the sign. Well, if you take the absolute value, that takes the sign out of the problem. It's always going to be positive. Right? So it doesn't really matter which one you put first. So let's find the distance between those two numbers, -2 and -9, on the number line. All right. How about Olivia? What am I going to fill in for A?
-2.
All right, I can put -2. And Caden, what am I going to fill in for B?
-9.
Yep, -9. Now, here we're subtracting a negative, so that's going to turn into what? Yep.
Positive.
Yeah, so let's just make that a positive right now. And then what's -2 plus 9?
Negative 7? Negative 2 plus
11.
9?
7.
7, right? Negative 2 plus 9, that's going to give you 7, same as 9 minus 2. And now the absolute value of 7 is 7. So 7 is the distance on a number line between negative 2 and negative 9. All right. That's it for absolute value. Any question on that topic? Most sections don't have this many little topics in them. It's more like one big thing we do for the entire section. Okay, so 2D coordinate system. In a two-dimensional coordinate system, you have number lines like we did before, but we usually call the number lines axes. The horizontal has a name, and so does the vertical. Does anybody remember the name that we give to the horizontal axis? Yep, Brady?
The x-axis.
Yep, that's the x-axis. And how about the vertical? Yep,
Y-axis.
the y-axis. And when you draw your x and y axes, they intersect at a point that has a name. What's the name where they cross? Martin?
The origin.
Origin. When you draw the axes, it separates the plane into 4 different areas. Does anybody remember what we call those 4 areas? Yep.
Quadrant.
Those are called quadrants. Yep. The quadrants are numbered 1 through 4, starting in the upper right, going counterclockwise. Oh, we didn't talk about this. So in quadrant 1, if you wanted to tell me a spot in quadrant 1, this is the thing that you use to tell me where to go in quadrant 1. It'll be a positive number, comma, positive number. What is the name of this thing? What do you call that? Yeah, Natalie?
Coordinate.
That's a coordinate, yeah, that's a coordinate. In quadrant 2, in the coordinate, the first number is negative, the second number is positive. Does anybody remember when you write a coordinate, what axis does the first number have to do with? Yeah.
X.
And the second number?
Y.
Y. Has to be in that order. Okay, another name for it is a coordinate, or you can also call it an ordered pair. If you had something like this, that's a coordinate, but that's a 3D coordinate. That would be called an ordered triple. Okay. We're not going to get into 3D a little bit. I just want you to understand there's different kinds of coordinates. 2D, 3D, 4D, all kinds of coordinates. I think that's everything I'm going to mention about two-dimensional coordinate system for now. Does anyone have any questions on that? All right, so the next topic is going to be more of a technology thing. So this is going to be on the graphing calculator. Okay. What I want to do is I want to type something in. So first thing you have to do is turn your calculator on. There's a button in the lower left that says on. You just press that. That's also the button you use to turn it off. When you're done with the calculator, press the second button in the upper left, it's blue, and press on, and that'll turn it off. All right, so this is the screen where I would do arithmetic. I'm not going to type in any kind of arithmetic. What I want to do is graph something. To graph something, in the upper left, there's a button that says y equals. Okay, we're going to press that button. If you have stuff typed in because somebody else was using your calculator, stuff like that, we're going to clear anything that's in there because we're going to type in our own stuff. So to clear anything, make sure your cursor is blinking on the row that you want to clear, and then press the clear button on the right-hand side. It's the button right below the 4 arrows. Okay, and then you can press the down arrow and you can clear the other one. When you're typing in a graph, it doesn't really matter which one of these you type it in on. I just usually use the first one I have available, which is y1. So what I want to do now is I want to type in x squared plus 10. So the first thing is how you get the x. The x is below the mode button, and it's to the right of the green button that says alpha. There's an x, comma t, comma theta. If you press that, you'll get an x. The squared button, that's the 1, 2, 3, 4, 5 buttons down on the left-hand side, x squared. And I want to do plus 10. On the right-hand side, my buttons are gray, on yours they're yellow. Those are the arithmetic buttons. Add, subtract, multiply, divide. Okay. Plus 10. While we're talking about the arithmetic ones, there's 2 buttons on the calculator that look like dashes. They're not the same. The button below the multiply sign, that is a subtraction symbol. So if you want to take 2 numbers and find the difference between them. The number below the 3 is a negative sign. That's not subtraction. That's what you put in front of a number if you want it to be the opposite. Okay? -3 is the opposite of +3. And you can see they look a little bit different too. The minus sign is a little longer. The negative is a little shorter. So make sure if you want to do minus, like you're doing subtraction, that's the button on the right that's in yellow. All right, so we've typed in x squared plus 10. The next thing we have to do is we have to set the size of the screen. Basically, that's like the size of the piece of graph paper that you're using. To do that, we're going to press zoom. And what we always use, if we're not sure where to start, okay, for now, is going to be the 6th option down, which is zoom 6. Okay, what zoom 6 is, it sets your window from -10 to +10 on the x, and -10 to +10 on the y. That's the size of the graph paper. So I'm going to do zoom. I'm going to press 6, and you see a little yellow circle spinning in the upper right. That means it's doing something. And it just stopped, so now it's done. Now, if you did everything that I did, your screen should look exactly like that. We typed in something to graph, but it's not there. How come? Where do you think that graph is? It's not there. Have a guess where it might be.
Off the screen?
It's off the screen. So what we have to do is we need it on the screen. So how do we get it on the screen? Well, that's where we need to zoom. Okay, we might have to zoom in or zoom out. Okay. So on this one, I'm going to give you a hint. I'm just going to tell you to set your calculator to a viewing window of -20 to 20 and -20 to 20. Okay, what does all that mean? Well, if you go back to your calculator and you press window, okay, that's the button right next to zoom. There's 4 numbers there that are really important. X min and max, Y min and max. We're not worried about what the other numbers do. Okay? If you want to know, the X scale has to do with how often you see tick marks on the screen, but I'll probably never change that. When they give you these 4 numbers, they're going to go in 4 spots on that screen. This is where each number goes. The first 2 numbers you're given are always the x's. Minimum first, maximum second. The next 2 numbers are the y's. Minimum first, maximum second. Okay. And if there's a question in the homework that says, what was the window you used on your calculator to solve the problem, I would want you to write down something like that. You'd have to tell me 4 numbers. The min and the max for the x, min and max for the y. Okay, so now let's put those in on the calculator. Remember, that's the minus symbol below the 3. So negative 20 to 20. You can try the other minus symbol if you want. It's just going to give you an error. If you want to see what an error looks like, go ahead and try it. Negative 20 to 20. And speaking of errors, if you get an error on the test and it has nothing to do with something we learned that week, I would fix your calculator for you. Because if it's nothing you've ever learned, I wouldn't expect you to know how to fix it. But if the error is related to something I taught you, and like if you put in this, and you say, oh, Mr. Hager, every time I put in negative 20 and I hit graph, is it going to give me an error?
No.
Huh. Or let's see, let's try it here. See what happens. Still giving me an error. Okay, well, it's not giving me an error. Usually it gives me some kind of error. Let's say I typed in something like x squared, and I wanted minus 10, and I accidentally did that negative. That'll give me an error. And you kept saying, every time I hit graph, oh, come on. All right, well, it's not giving me an error. Well, anyway, if the error is related to something you learned that week, I'm not going to help you fix it. But, all right, so we typed in our window, press the graph button, and now you should see the parabola on the screen. All right. Does anybody still not have the graph on the screen? Okay. Sometimes finding the window is not always the easiest thing to do. So just kind of watch me do this. So I'm going to type in something and hit graph. And if I wanted to draw a picture of what I just typed in, that's not a good window. Okay, it's going off the screen. It's going off the screen on the bottom a little, but it's going off the screen on the top a lot. So I don't know how much higher I need to set my Y max, okay, but I could take a guess. I could try setting it at like 150, and I could try making my Y min a little lower. And the goal is so it doesn't go off the screen when it turns. That's good. That's good. That's perfect now. Right? So it takes a little practice to get used to what to set those numbers to. But that's a good window for this problem. Okay. So any question on how to type in mins and maxes for a window? And if you forget, you can always go back to the video. Just write down the time, like 11:35 or so is probably when we learned how to type in the window. Okay, last thing. So not related to the calculator is the distance and midpoint formula. So the distance formula is what you use if you have a point here and here, and you want to know how far apart they are. Now, technically, when we use the distance formula, we are not directly finding the distance between those 2 points. Measuring distance on a slant like that, that's hard. Okay, that's really hard to do, like on graph paper. What's easy to do is measure distance that's horizontal and measure distance that's vertical. Because you got grids when you have graph paper, you can just follow the grid lines. If you can figure out the length of the bottom, and you can figure out the length of the height, that blue line, in this right triangle, there's a theorem you can use to find the long side. Does anybody know the name of the theorem I'm thinking of? Ariel? Wait, no, yeah.
Yeah, a squared plus b squared equals c squared.
Okay, and what is that? Yep,
Is it Pythagorean theorem?
the Pythagorean theorem. Yep, and that's exactly what that formula is. The Pythagorean theorem says if you want to find the length of the hypotenuse in a triangle. You take the length of one side, and that's exactly what that calculation will give you, length of the bottom. You take the length of the other side, and that's what that calculation gives you. That's the height. It's the difference in the y values. So that's the height. You take those two values, you square them, add them up, and take the square root, and it'll give you the hypotenuse. Okay, so if you ever forget the distance formula, but you know the Pythagorean theorem, well then you didn't forget the distance formula. It's the same theorem. All right. So let's see if we can find the distance between those 2 points. Now, the first thing that I usually do is, there's a lot of stuff in that formula. To find the distance, I'll write down the square root, 2 sets of parentheses, addition sign between them, subtraction sign inside them, and squares. Now that I've written down my formula, I don't have to think about what the formula is at the same time I'm trying to fill it in. Now I just fill it in. Okay. Right now I've got 2 choices for x1. That's the first number I plug in. What could my x1 be? Yeah,
5.
could be 5, or it could be 1. Could be either one. I'll go with the first one you said, which was 5. So if my x1 is 5, what's my x2? Okay, yeah, it's going to be 1. So 5 minus 1. And then we're going to do 6 minus 4. All right, so let's go through and see what we get. Maggie, what's 5 minus 1?
5 minus 1 is 4.
And when we square that?
8. Oh no, 16.
16. Yep. Gracie, how about 6 minus 4?
2.
And when you square that,
4.
you get 4. And now that gives you square root of 20. But the square root of 20 is a root that can be simplified. I don't mean get a decimal. I mean you can reduce it. What 2 numbers can you multiply together that give you 20? And one of them has to be a number you can take the square root of easily in your
Can you
head.
repeat that again?
What 2 numbers can you multiply that give you 20? But I want one of them to be a number you can take the square root of in your head. So I don't want like 10 times 2. That's not going to work.
Only one of them has to have the square root?
Only one of them, yeah. Yep,
5 and 4.
5 and 4. So we're going to break 20 up. Just like that. 4 times 5. When you have 2 numbers multiplied under a square root, you can take the square root of each one of them separate. That's a rule about square roots. Now, the square root of 5, I'm not going to be able to do anything with. But the square root of 4, I can. What is the square root of 4? Yep.
2.
2. So the real reason I did this is not necessarily to find the distance between 2 points, but to reduce a square root. That doesn't always happen, but if it does, you need to reduce the root. If you have a way that you reduce square roots and you get that answer, that's fine. If you don't have a way, well, that's how I do it. All right. So any question on the distance formula? All right, so last formula, midpoint. Let's say that you had, again, you had 2 test grades. You had like an 82 and a 93. And I got to give you a grade on your report card. Let's say that's all you had. There's like no other homework, no participation, just 2 test grades. What would I do with these 2 numbers if I wanted to figure out the grade I'm going to give you on your report card? Yeah?
Add them together and divide by 2.
Yeah, I'd add them together and divide by 2. And what does that give you? That's the average. That's exactly what the midpoint formula is. You add two things together and you divide by 2. So the midpoint formula is the average of the x's, add them up and divide by 2. And it's the average of the y's, add them up and divide by 2. So this formula is not telling you how far apart 2 points are. It's telling you the location that's halfway between them. All right, so let's fill this in. If you are going to make a reference sheet for your test, which you can, that is definitely a formula I would put on it along with the distance formula. Okay. At the end of the, well, tomorrow is going to be our last lesson for the week. So in that video, I will put test topics, and I'll have a list of everything that you would need to know from today and from what we do tomorrow. Oh no, I'm sorry, no, today's on Tuesday. So yeah, I'll do that on Thursday. It's not Wednesday yet. All right, so let's fill this in. All right, Sadie, what is x1 in this case?
-5.
Sure. And x2?
3.
3? Okay, we'll do that out in a second. Alex, what's y1?
2.
Yep. And y2?
7.
7. Okay. So when you're doing the midpoint, you usually don't have to deal with square roots, but you do have to simplify as much as you can. What's -5 plus 3?
-2.
And then divide by 2?
-1.
-1. That's why I erased the fraction bar, because I realized it wasn't going to end up as a fraction. How about the next one? 2 plus 7 gives me 9, but because that's odd, you can leave it as 9 over 2. If you want to write 4.5, that's fine. What I generally am not going to be looking for is a mixed number. We don't really use mixed numbers. Okay, so a lot of different topics in that section, like little kind of mini topics, but hopefully besides the calculator, all stuff you've seen before. Okay, any questions? Okay, so that is the homework for tonight. So remember, page 11, you're going to have to go on Schoology, and if you click on section 1.1, the PDF will be there with those questions. Or if you downloaded the whole chapter, then you'd also have them. 3 through 11, those are just odds. 12 and 15, 20 to 22 is all. 20, 21, 22. And then 28, 31, and 44. Okay, so we did 1.1 today. We're going to do 1.2 tomorrow. And then on Thursday, we're going to do half a section because it's kind of a lot in the 1.3. So we'll do half of 1.3. We're going to save the other half for next academic week.